Okay, looking at section 15.1, where we're working with right triangle trigonometry, we're going to discuss things like the cofunctions, the trig functions, special angles, special right triangles, and the angles in there. This is a trig table. These are similar to the values that your calculator would have. You can see that for each degree there are ratios indicated of what like opposite to hypotenuse would be if you were looking under the sine column. So when we work with this stuff, that's really what's your calculator is accessing, is a ratio number. Now, looking at the triangle that we have here, we are working with angle beta here. This is Greek symbol beta, and you can see indicated on our triangle where beta is positioned. So let's talk about the sides of the triangle and what their position would be. When I'm at angle beta and I go across from it, the side across from it is called the opposite side. And the side right next to that angle that helps form the angle, that's the adjacent side. And of course, the longest side across from the right angle is the hypotenuse. So we have our sides identified, which will help us calculate out sine beta. So this really is the SOHCAHTOA idea. For sine, we know what it compares. It compares opposite side to the hypotenuse. So opposite over hypotenuse. This seems like a repeat from chapter 14, and it is a little bit. It's setting stuff up for us, though. So let's just rehash this. We know cosine is the ka idea, so adjacent to hypotenuse. Tangent compares, that's TOA, the opposite over the adjacent, so opposite compared to adjacent. Cosecant is the reciprocal function to sine, so cosecant will be hypotenuse over opposite. Secant is hypotenuse over adjacent. It is the reciprocal to cosine, and cotan is the reciprocal function of tangent. So adjacent over opposite. Find the sine, the cosine, and the tangent values for angles D and E in the figure provided here. And when I'm looking down this first column, the angle that they're mentioning is angle D. So that's going to drive me up to angle D on the triangle. You'll notice I have an I sitting up here because that's kind of my vantage point, isn't it? So I'm kind of up here at angle D looking down. That would make the side opposite the angle my opposite side. Why don't you go ahead and label these out? That'll make it easier for you. The side that is immediately that forms the angle, that is our adjacent side. And of course, opposite the right angle is hypotenuse. We are taking this from angle D. So now if I want to describe the ratio from sine of angle D, the side opposite has a value of 36. The hypotenuse has 85. And I don't believe that will simplify, so we'll just leave it 36/85. Go to cosine D. Take a guess. What do you think it will be? We know cosine compares adjacent to hypotenuse. Look to your triangle. Find that adjacent side. It is 77. The hypotenuse was 85. Tangent is TOA. It compares opposite to adjacent. So from angle D, my opposite side is 36, and the adjacent side is 77. The second column asks for cosine, sine, and tangent, but we're now looking from angle E. So we have to position ourselves down here at angle E. Now our point of view takes a little different perspective. The side opposite now becomes the 77 unit length side. And 36 is adjacent to my angle E, so this is the adjacent side. Hypotenuse, of course, is still opposite the right angle. The cosine of E, we're comparing adjacent to hypotenuse. The ka idea, right? So adjacent to angle E, that would be 36. Hypotenuse is 85. Opposite compared to hypotenuse will help us find the ratio for sine from angle E. Opposite is 77. Adjacent, or not adjacent, but hypotenuse. I'm not sure I said that right. Opposite is 77. Hypotenuse is 85. And tangent, of course, compares the opposite to the adjacent. Opposite 77. Adjacent is our 36. Of course, we could take a calculator and get values on these and get them into decimal form, which you could do. I'm going to leave them just in the fraction form. Cofunctions. For any acute angle A in standard position, sine and cosine are called cofunctions. So this is where it starts getting a little confusing because we've had reciprocal functions and now we're picking up cofunctions. So I would know that sine of A is equal to the cosine of 90 minus angle A. And likewise, cosine of A is equal to sine of 90 minus A. You can see this relationship on those previous triangles that we did. Sine from angle D was 36 over 85. Now if I take angle D and subtract it from 90, it gets me the other angle, angle E, and cosine of angle E is also 36 over 85. That's because these are cofunctions. And 90 minus one of the angles gives me the cofunction idea here. Tangent and cotangent are cofunctions. And 90 minus angle A. This angle A we're referring to is what we're starting with for an angle written out as cotan of angle A. And 90 minus A. Secant and cosecant are cofunctions, so 90 minus A and another 90 minus A. So those are pretty easy to write down. They're all 90 minus A. And now examples A, B, and C ask us to write each function in terms of its cofunction. So the sine of 9 will match up with the cosine of 90 minus A, or 90 minus R9, which turns out to be cosine of 91. I want to open my calculator here a minute. I'm going to have to pause for a moment here. Okay, got the calculator on the right screen. I'm going to hit clear. I got to hit my mode. I got to get over to degrees, so hang on a second here. Got it. Okay, so what I wanted to exhibit was, let's put in sine of 9. That gives me 0.156. And let's also look at the cosine of 90 minus 9, or I could have put cosine of 81 in there. And voila, they do take on the same values, don't they? That is what a cofunction, the characteristic of a cofunction. Cotangent is a cofunction with tangent. So cotangent will be equal to tangent of 90 minus, I did put 91. Make that an 81 back on that first problem. All right, tangent of 90 minus 76. And this will be tan then of 14. Cosecant and secant are cofunctions. So we'll have secant of 90 minus the original angle. The original angle is 45. And we'd get secant 45. On your calculator, I'm not sure I mentioned this the other day, you will notice that there are not any cosecant, secant, or cotangent listed down. What we have to do to get those is just go 1 divided by like cotangent, or tangent to get cotangent. We'll practice those probably in another lesson, but we can get to those values. All right, example 3, given a right triangle ABC with right angle at C, find the unknown side length using the Pythagorean theorem, and then find the values of the 6 trig functions. All right, so we're given just a plain old triangle here, no vertices listed. I'm going to go A, B, and C. Placing the little letter, so those are my vertices, those are my angles. Little letter A goes opposite big angle A. Little c goes opposite big C. Little b is the side opposite angle B. So that is a must that you get those in the proper spot. Now, they gave us some values. So C was equal to 7, B is an unknown, and A was 6. Let's find B. We are going to, and I knew that C had to be positioned at the right angle, so that's why I put it there. A squared plus B squared will equal the hypotenuse squared, which is our C value on this picture. So let's plug in 6 squared for A. B squared is going to stay open. C is 7, so that'll be a 7 squared. Do the squaring, we get 36 and a 49. Now let's solve for B squared. I'm going to do one more line here. So I'm going to get 0 plus B squared equals 13. That means B squared equals 13. B is equal to the square root of 13. So B, not exactly the nicest number here. B is square root 13. Now into the 6 trig functions. So sine, I think of the SO function, opposite over hypotenuse. What is our perspective? Because which side is opposite? Well, that all depends on the perspective that we're taking. So we are positioned at angle B. It's kind of like you're looking from angle B to find those angles, or those opposite sides. So B, this would be opposite, and then hypotenuse. So I'm going to have root 13 over 7. Its reciprocal function will be 7 over root 13. I suppose we should rationalize this, so we're going to multiply by square root 13 over square root 13. And that's going to give us an answer of 7 root 13 over a nice normal 13. Cosine. Cosine, I think of ca when I think of cosine. It compares adjacent to hypotenuse. So on our triangle, go to angle B. Adjacent side is 6. Hypotenuse side is 7. Might be a push. Reciprocal function, let's just reverse those. 7 over 6. Tangent is TOA. It compares opposite to adjacent. From angle B, opposite is root 13. Adjacent is 6. Its reciprocal function would be 6 over square root 13. We'll rationalize this to get the radical out of the bottom, getting 6 root 13 over 13. 30, 60, 90 right triangles. This is something you probably studied in geometry, maybe even a little bit of work last year in Algebra 2. And we're starting out with an equilateral triangle, which means that all the sides are equal, all the angles are equal. So you can see how we're starting out with congruent sides, 2, 2, and 2. I'm going to split this triangle down the middle. That'll give us a 1 on each side, and it generates a bisect of the vertex angle there at the top. So now I'm into a 30-degree angle on each side. It generates a 30, 60, 90-degree right triangle that we know side lengths 1 and 2. And we want to find then that missing side of x. So let's do Pythagorean theorem. And we're going to have x squared plus 1 squared equals 2 squared. Or x squared plus 1 equals 4. Or x squared equals 3, making x the root of 3, square root 3. That gives us the recipe or the pattern for a 30, 60, 90. I know the short leg has a value of 1. This is my short leg. And then there's a longer leg. It's opposite the bigger angle, 60 degrees, and it has a value of root 3. The hypotenuse has a value of 2. On your table, let me just see if it's on the screen ahead. Yeah, it is. Okay. So on yours, you've got blanks over here that we need to fill in. So we're going to look at the sine of 60 degrees. Remember, sine is so opposite over hypotenuse. Opposite side from 60 degrees is root 3, and hypotenuse is a 2. So I get root 3 over 2. Cosine from 60 degrees, I need the adjacent side, which is 1, compared to the hypotenuse, which is 2. If I take my calculator and I key in cosine of 60, look at what happens. We get an answer to cosine of 60 as 0.5, the numbers that we just indicated off of our special right triangle. Tangent of 60 degrees, well, tangent is TOA. It compares opposite and adjacent. So opposite would be our root 3. Adjacent is a 1. So I guess this simplifies down to just root 3. And you could check on the calculator to see if we get the decimal value of root 3. We would. The other special right triangle is a 45-45. And we know in a 45-45, if we have base angles that are congruent, then the sides opposite them are congruent. So we've indicated that by just giving them a simple value of 1 and 1. Let's go find the r value. So you can see here the Pythagorean theorem is already set up for us. 1 squared plus 1 squared equals r squared. Add the 1's together, we get 2 equals r squared. Or we get root 2 equals r. Just figured it out, didn't we? There is our r. It is root 2. So go ahead and pop that on your chart. I'm going to move my screen. Here's the triangle we just talked about. Let's look at sine, cosine, tangent. Sine, opposite over hypotenuse. From a 45-degree angle. Hey, wait a minute. They're both 45. Okay, we'll pick one then. I'm going to pick the base one. Opposite side is 1. Hypotenuse is root 2. Let's fancy this up. And we get root 2 over 2. We rationalized it by multiplying by square root 2 over square root 2. Cosine of 45. Cosine is ca, adjacent over hypotenuse. Adjacent side is 1 now. I'm no longer working with the opposite. So we get adjacent of 1, hypotenuse of root 2. Oh, well, that looks just like sine did. Correct. They are identical. We'll get an answer of root 2 over 2 once we rationalize it. Tangent is TOA. It compares opposite and adjacent. Opposite of 1, adjacent of 1. So it compares 1 to 1, and we get an answer of 1. So there's some special right triangle values. We will end up memorizing this, believe it or not. You will end up memorizing this very soon. Probably in a couple weeks, we'll get to a state where we're working with a unit circle and we will have many of these values memorized. So right now it's a nice reference chart for you, like the sine of 30 degrees is 1/2. The sine of 45 degrees is root 2 over 2. The sine of 60 degrees is root 3 over 2. So easy chart to read. Your homework can be found on page 707. And let's see, it's just asking for sine, cosine, and tangent. And I would just write them out. You're going from the viewpoint of angle A. So down here is kind of my eyes looking at this problem. So this would be considered the opposite side from angle A. I'll let you figure out adjacent and hypotenuse. What you want to do then is compare n opposite to hypotenuse p and write out the other two as well. 5 through 10, you are just matching up. Sine of 30 is one of these items. Sine of 30, I believe, well, maybe I'll just take a look on the chart. Look at a messy chart here. Sine of 30 degrees, oh, it's 1/2. Okay, so sine of 30 degrees is 1/2, which would be option, I can't see it. Here we go, C. So 5 is C. That's how I would do that block of work. And then 12, you've got to build your own triangle. They talk about the right angle at C, so make sure that you structure your triangle such that C is your right angle. And then you can put A and B. Remember, little letters fall in across from their vertices. So then just go in and label these up. You will have to calculate C using Pythagorean theorem. Cofunctions, you've got instructions on your notes. Look up that second little grouping where we worked with cofunctions on the front side of notes. All right, we will see you on Monday.